Section 5.1, Polynomial Functions. We're going to classify polynomials today. Is it monomial, binomial, trinomial? And then is it quartic, quadratic, linear? What kind of equations are they? We're going to also graph polynomial functions and describe their end behavior. A monomial is basically one thing. It's a real number, a variable, or a product of a real number and one or more variables with whole number exponents. So, for instance, 2x, it's one term, so it's a monomial. The exponents that it has doesn't necessarily matter. It's how many terms it has. So you have to think of things like when you are putting like terms together. Once you do that, how many terms do you have? Okay, that's how you kind of classify that. A polynomial is a monomial or sum of them. The degree of a polynomial, you look for which term has the highest exponent or exponents, and then that is the one. And we'll look at more of those here in a little bit. Standard form is arranging them in descending order. So you're always going to put the highest exponent first, then the next one down, and then the number, or you keep going down in descending order. There's some in a table on page 281. So let's look at those for a second. Just write the ones you don't know. If you know them all, then obviously, you know, that's totally fine. Okay, so looking at monomial is one term. I'm not looking at the degree part of it. I'm only looking at like the right side of the table. So I'm just going to jot some down. One term, number of terms. One monomial. 2 binomial. I think you'll probably know these first three. 3 trinomial. 4, and then there's also a 5. 4 is quartic. 5 I think is quintic, if I remember right. Let me look. I know that there was one in the examples here. Pretty sure those are it. I'm going to look them up later just to make sure. So for me, 4 and 5 were the only ones that I was kind of unsure of. Let's look at the polynomial examples. They're going by the thing in the middle, and then they're branching off to the side. So the polynomial example with the number 5 in it, and again, these are on page 281. There's no variables. So if you saw a variable, it would be like x to the 0. Well, that would be 0 degree. So they're going from the 5 left, and it's going by degree. And when you look at it, there's one term, so it would be a monomial. So it would be a 0 degree monomial or a monomial of degree 0. When you look at the x plus 4, there's 2 terms because there's a plus between it. So that would be binomial. When you look at the highest exponent that is there, it'd be x to the first. So that would be a first degree binomial. Okay, so you're going to do kind of classify by degree and by terms. The next one says 4x squared. Well, there's no pluses or minus in there, so it's just one term. So that one is a monomial. So they're not actually going up by table. They're looking at the example only. The highest degree of the exponent would be a 2, so that would be quadratic. The next one has pluses or minuses, so you look at those things that are being separated. There are 3 of them, so that would be a cubic. Oh, that's where I got it, is I'm doing degree instead of number of terms. So I'm going to erase these last 2. I knew I saw that somewhere. I'm going to just go like that. Degree. Okay. So when you look at that one, there's 3 terms. The highest exponent is a 3, so it's cubic, and you call it a trinomial. For the next one, there's 2 terms, so you call that a binomial. And then the highest exponent is a 4. So by degree, that one would be a quartic function. The next one has pluses and minuses, so you count how many terms there are. There are 4. Once you get past 3, they call it a polynomial of 4 terms. So evidently 5 would be a polynomial of 5 terms, and so on. Okay, so when you look at that one, the highest exponent is a 5. That one they call quintic. So it would be a quintic polynomial of 4 terms. One thing that I want you to be aware of, but you won't really necessarily run into it in this lesson because we're only going to be really working with cubic and quadratic, is if you had something that looked like this, that right there is a 5th degree monomial. So there's one term, it happens to have 2 letters in it, and when it says the highest degree, you add the exponents together. So it would be 2 plus 3, you'd get 5. Okay, you're not going to run into that, but I know we talked about that in geometry, so I'm just kind of throwing you back to when you were there. Like I said, I doubt you're going to see anything like that because we're going to keep it cubic or quadratic. What we want to do is write each polynomial in standard form. That's the descending thing, so descending order. And then we're going to classify by degree. So that would be constant, linear, quadratic, quartic, or quintic. And then we're also going to classify by terms. So we're going to have a couple of different names on there. All right, so for A, is this thing in descending order? Nope, so let's put it there. So I'm going to put the highest exponent first, then the x, then the number. So if there are 3 terms, what's it called? Trinomial, that's part C. And what's the highest exponent? 2. So what do you call that? Quadratic. Okay, so I'm just flipping back up to my list that I made. That would be a quadratic. Whoa. So if you were going to name this one, it would be a quadratic trinomial. They always do the highest exponent part first, the degree, and then they do the number of terms after that. Okay, let's do this one. Now, don't count the terms right away. You want to make sure that everything is as simple as you can make it. So if there's terms that actually go together, put them together first. Don't count that as separate terms. So I'm going to look for the highest one first, which would be x to the 4. Notice here that we have a couple x squareds in there. I'm going to put them together. I'm not going to count them as separate terms. I'm going to go plus 4 x squared, so all those are done. Then my 4x, then my 12. So don't do a polynomial of 5 terms before you've looked at them. Put them together first. Okay, so What is a 4-term polynomial called? Polynomial of 4 terms. Poly of 4 terms. And the 4 means quartic. So if you were naming this one, you would say this is a quartic polynomial of 4 terms. So basically when you're naming it, you would put B and C together. So if I added a D that said name it, that's all you're going to do is put quartic polynomial of 4 terms. Okay, here's where this is going to be new. So starting right here. You might want to jot down what things are, but if you get it once I've talked about it, certainly, that's totally fine. The degree of a polynomial function affects the shape of its graph and determines the maximum number of turning points that affects and also affects the end behavior. We did the end behavior already. No, we haven't. That's in this section. Turning points are places where the graph changes direction. So I'm going to do a quick little sketch just to kind of show you what turning points are. Okay, so notice the end behavior on this one is up and up. There are turning points, and turning points are if you're cruising from left to right and you go down and the sign changes and you go back up again, that's what turning points are. So there would be a turning point right here, there would be a turning point right there, and there would be a turning point right there. So it's every single point that the graph changes directions and goes the other way, okay? So places that the graph changes direction. End behavior is what's it doing on the far left, what's it doing on the far right, and we're going to talk about those now. This part you definitely should write down. I'm just going to go, I'm going to put it all out there right now. Okay, so they have kind of a little table in the book, but I kind of made it a little bit different because I think it's easier to do this way. It's the same information, just put on paper a little bit different. So if n is even, you're going to do one of the top 2 things. If n is odd, you're going to do one of the bottom 2 things. Okay, so that's the first thing you look for is the highest exponent even or is the highest exponent odd? If it's even, you're going to do something if it's positive and something if it's negative. So this one, of course, if a is greater than 0, I'm going to say a is positive. But that's what the greater than 0 means, is just that number is positive. If a is negative, that means if a is negative, that means it's less than 0. Okay, so just a little hint about how to read the greater than 0 part and the less than 0 part. Now, what does up and up mean? So on the left side, it goes up. On the right side, it also goes up. Okay, so the up is the left side first, then the right side. So this part right here stands for the left. This one right here stands for the right side. So if they ask you what is the end behavior, you're going to say, okay, I'm going to look at my equation. I'm looking at the highest term. The n is even, so I'm going to go to the top section, and the number is positive. I'm going to say up, up. The first up goes with the left side. The second up goes with the right side. You could do up and up. You can do up slash up, whatever you want to do there. It's going to go down and down if a is negative. So think about it like this. If it's even, if it's greater than 0, both sides are positive, which means both sides go up. If it's negative, it means down, and both sides are going to go down. Now, if n is odd, then you have one of each. And think of it like this. You're going to go down and up. So on this first one, it would maybe look like this. Okay, also, if it's odd and a is greater than 0, wouldn't that be an increasing function if a is greater than 0? So I'm going to say this is an increasing function. This one right here would be a decreasing function. And this one would be kind of like the same thing going the other way. Okay, so left side goes up, right side goes down. On the down and up, the left side goes down and the right side goes up. So odd is one of each, even, both are the same. They're either both up or both down. For parts of these, you're just going to have to look at it and say what's the end behavior. You wouldn't actually necessarily have to graph it. For other parts, you might have to throw something on a graph. And I think that's more tomorrow. Okay, so the number of turning points, you look at the degree of it. So you look for the highest one. And let's say it's a 5. It's one less than that. So if the degree is 5, you have at most 4 turning points. It doesn't mean you always have 4. It means you could have 4 if it's a crazy graph. And most of the time, you don't have that many. Okay, so consider the leading term in each polynomial. What's the end behavior? Okay, so if they're in the right order, which both of these are, if they're not in the right order, change them to that first. So we look at only this term. Okay, is the exponent even or odd? So we're going to go odd here. Is the number positive or negative? Positive. So we are looking for odd and positive. So not the first group of things you wrote, it's the second one. So I'm going to go back so you can see it. We have odd and positive. So you go back and you look, it's odd, and the second one is, or the first one is positive, so it's down, up. And that's all you have to write, is down, up. Which means down on the left side, up on the right side. So you look for those things, you go to that little table that you have, and then you just determine what it is. So if you knew where these things, like for instance, crossed and what the graph kind of looked like, you could kind of draw that last part in without having to plug in a bunch of numbers. Okay? The 3 is an odd number, so the exponent is odd. So we're going to go to this section right here. Wait, I'll go a little bit more. So we're going to the odd part. And then, is it positive or negative? Okay, it's positive, so I'm going by that first one. Okay?
So does the 3s even really matter?
No. So it's the highest one.
You just always look for the exponent to determine?
Yes. So first you put them in descending order if they're not. For this one, the only term that affects what you're doing for this one is that right there. The other part affects the graph of it, but we're not really concerned with that yet. Did you have a question too?
No.
Okay. Anybody else? So there could be 14 things following this one. Those 13 things don't matter. It's only the highest one. So let's do one more. For this one, they are in descending order. So I'm looking at only this one. Okay, is it even or odd? Okay, so it's even and negative. So we look in the even section. The second one, so the first one's always positive in the list. The second one's the negative one. So even and negative would be down, down. So if you guys had this on a quiz, like for instance, when is it, Monday? Quiz on Monday. If you had to explain, all you'd really have to explain is this one is odd and positive, so it's down, up. Okay, you'd have to include these things. Doesn't matter which way you include them, but this one is even and negative, so it's down, down. Okay, so what's the graph of each cubic function? Describe the graph, including the end behavior, the turning points, and the x and y intercepts. So I've changed this one just a bit. We're not going to focus too much in this section, like the exact turning points and what they are, because the book assumes that you're all have a graphing calculator in your hands. So if we did, all we would have to do is use our tools. We'd either use the maximum or minimum, or we would choose the 0. So we would be able to find those. I'm not going to make you do the quadratic and everything here. We're going to get more into that in the next section, but let's do this one for now. So we need end behavior. So on this one, it is odd or even. Odd, and there's only one term, so this one is odd. And positive or negative. Positive, which says what? Is it down, up, or up, down? Down, up. And you would need those exact things for this part. For the turning points, I'm not going to make you say what they are. I'm going to say how many there could be. So in this one, the highest exponent is a 3. So 3 minus 1 equals 2. I'm just going to say 2 possible. So you take that highest exponent, you subtract 1 from it, and that's how many possible turning points there could be. Doesn't mean there always is, but there could be. And basically, like if you were graphing, this is what you would use to think, to kind of check to see if you were right. You would check, does my graph go down on the left and up on the right? Do I have no more than 2 possible turning points? And so on. Now, the other part that I want you to be aware of is the x-intercepts and the y. And remember, that's when on one of them you put a 0 for the x, on the other one you put a 0 for the y. Okay, so you have to do a little bit of solving on this one, but it isn't something that you haven't done before. So if I put a 0 in for the x, what is the y? 0. So that's 0. If I put a 0 in for the y, what do you get for the x? Wouldn't you get 0 again? You don't always get 0, 0 for both of them, but on this one you do. So this one only crosses the x and the y axis right now at 0, 0. Sometimes there's more than one. Okay, let's do one more. So with this one, what are we looking at, the 3x or the negative x cubed? Yep, so I'm going to reorganize this one. It should look like this, negative x cubed plus 3x. So don't just go with the one that's listed first, look for the highest one. So is the highest one even or odd? And negative. Okay, so we're in the second section and we're negative. What's that one do? Up, down. Someone's having fun out there. Okay, how many possible turning points could there be? 2, and again we take the 3 and we subtract 1 and we can just put 2. I'm not going to put possible on there because we know that's what it means. And then we find our intercepts again. One when x is 0, the other is when y is 0. So if I put zeros in for the x's, I get 3 times 0 minus 0 cubed, which gives you 0. If I do 0 for the y, I'm going to put that one over here. Okay, that's what we've kind of been working up to. So when you're looking at this thing, you're going, okay, I need to solve this somehow. I'm either going to factor it, I'm going to put it in the quadratic, I'm going to do something with it. Well, if it's cubed, you can't put it in the quadratic like it is. So you couldn't go, like your a is -1, your b is 3, and your c is 0. You got to get that out of there. Most of the time, you're going to be able to factor it out. So I'm going to take out a negative x. And I'm going to have left a -3 plus x squared. Okay, and I would probably do that in the opposite order, but it doesn't necessarily matter. This one right here is going to give you 0, right? Negative x equals 0. This one would be negative 3 plus x squared equals 0. X squared equals 3. X equals plus or minus the square root of 3. Kind of got small down there. Oh, I have more room. Let me do that in a little bit bigger. What's that, like 1.73 or something like that? Okay, so there is a number at negative 1.73 on the x-axis. There's a point at positive 1.73 on the x-axis, and it also crosses at 0, 0. Okay? So here, I'm going to go with those. So really the y-intercept on this one is the 0, 0, because that's really the only one that touches the y-axis. But you'll be able to use now, if it's something like this, like if you didn't know how to solve this part, you could do the quadratic with that one, where a is 1, b is 0, and c is negative 3, as long as you reorganize them and put a 0 in for that part that you're missing. So you would get exactly the same answer as I got solving it like this. So when you get to that, no graphing. Also, yesterday, did you guys graph all those? Nobody graphed, did they? Good. Did you see my update? I'm hoping you did, because after you left, I'm like, oh, somebody asked last hour, do we have to graph all these? I'm like, no. And I was hoping you guys didn't, so good. This one you don't have to graph either. You're just giving those basic pieces. Let me see if we're doing this one. Okay, this one. What is the degree of the polynomial function that generates the data shown below? And you might want to jot one of these down because it's different, but it's totally not hard. Okay? It is not hard. You guys kind of did something like this in Algebra 1, like toward the end of the year. I remember seeing this one in the book. So what we're going to do is we're going to do differences of the y's until the whole column of numbers is the same. And we're just going to count how many times we have to do that before they're the same. So I'll let you guys get that table. It's always going to be the one that's underneath, subtracting the one that's above it. So that's why I kind of jotted down this y2 minus y1. So here's what I'm going to do. And I'll show you on this first one. It's negative 7 minus a negative 1. Otherwise, I'll probably just do it. That would be negative 7 plus 1. So you get negative 6. You guys could just grab your calculator if you wanted to and just jot them in like that. You don't have to show work, you just have to do it. The next pair. And you have to do all of them. You can't like skip numbers. The next one would be negative 3 minus a negative 7. That would be negative 3 plus 7, which is 4. So we can already tell that it is not a first degree because the numbers are not turning out the same, but we still have to kind of keep doing that. Okay, then I'm going to go to the next one. 5 minus a negative 3 would be like 5 plus 3, or 8. 11 subtract 5 is 6. 9 subtract 11 is negative 2. And negative 7 subtract 9 would be negative 16. So you kind of get some crazy numbers. So this one would be first degree if they all matched, but they don't. So we're going to do it again. 4 minus negative 6 would give you 10. 8 subtract 4 is 4. So we already know it's not going to be second degree. We have to do another one after this one. 6 minus 8. Negative 2 minus 6. And negative 16 plus 2 would be negative 14. And then we do it one more time because that column doesn't match yet. We're going to do 4 minus 10, negative 6. Negative 2 minus 4 would be negative 6. So it's looking good so far. Negative 8 subtract a negative 2 would also be negative 6. And negative 14 plus 8 or subtract a negative 8 would also be negative 6. So when those numbers match, you have found the degree that you are looking for. And that is the polynomial function that generates this data. So you'd have to keep going and find a third degree something there. Okay, so we're going to do this got it one together. Whoa. Hold on, let me get back to it. Okay, so the final column needs to be the same. And once it is, you're going to count how many times did you have to subtract. The first time we subtracted, they didn't match. The second time we subtracted, didn't match. The third time we subtracted, did. It's degree 3. You don't have to say what it is. You would just, if you had to find one, you would know that once you got to something to the third power, then you would be on the right track. So we're going to do one more of these because this part is totally different. So let's do this got it question together, and we'll figure out what degree this one has to be. You can write it down if you want to and try it. You can just watch, whatever. This one I won't make you write down. So really the X's here don't mean anything. Okay, you don't have to even look at them. We're only paying attention to the Y's. Okay, so negative 16 minus 23 is going to be a big negative number. Negative 39. Negative 15 plus 16 would be a 1, so we already know that it is not a first degree. Negative 10 plus 15 would be 5. Negative 13 plus 10, and I'm only saying plus because there's 2 negatives in a row, would be negative 3. Negative 12 plus 13 would give you 1, and 29 plus 12 would give you 41. So it's not 1. We're going to do it again. I'm going to do this one in a different color. One subtract negative 39, so we're adding them, gives me 40. 5 subtract 1 gives me 4. Negative 3 subtract 5 gives me negative 8. 1 plus 3, because you're subtracting a negative, gives you 4. And 41 subtract 1 gives me 40. Now notice on that one that it kind of went down and then it went back up. The numbers were the same. That doesn't happen all the time. It just happened this time. So the last one, if you look at that one, the numbers were completely different. 10 for negative 2, negative 8, negative 14. So they don't have to be the same. Hopefully it's leading to the next one that might be the same. We'll check it out. Okay, so 4 subtract 40 would be negative 36. This is not the one. Negative 8 subtract 4 gives you negative 12. 4 subtract negative 8 gives you positive 12. and 40 subtract 4 gives you 36. So it is not a third degree. Let's try one more. Negative 12 plus 36 would be 24. 12 subtract negative 12 would be 24. 36 subtract 12. 12 gives you 24. So the degree that generates this data right here would be fourth degree. If you were using your calculators on this, if you guys all had one, you could plot the points and then try different equations. So remember how we generated the parabolas and got equations for it? Obviously, if you got an equation and you did it and it didn't cross the points, that is not the one. So you'd go to the next higher one and the next higher one. So if you had a calculator, that would make this pretty easy and pretty fast. But this is not hard, it's just different. So you can determine degree that way as well.